Hi everyone, welcome back or welcome. I hope you're all doing fantastically well. And so today we are going to be talking about the basics of probability. This work is specifically focused on IGCSE level. So if you're in IGCSE, this video is just for you, especially if you struggle with probability and you either are just starting out or want to go back to the basics in order to understand exactly what you're doing in preparation for your exam. So this video will help either one of you, or if you're just interested in probability and you want to learn something new today. All right, so before we get into the calculations and the questions and the numbers and everything to do with maths, let's try and figure out what probability actually is. Now, probability is, put as plainly as I can, the chance of something happening or not happening. Okay, so what do I mean by happening, right? That is linked to events. So in probability, we use the idea of scenarios or events. So events can literally mean anything. I don't mean like a party or a wedding event, or that's not what I mean. I mean absolutely anything that happens. So you eating dinner is an event. You falling up the stairs is an event. You pulling a bead out of a bag is an event. Right? All of those things are all events. And there are chances those things can happen or not happen. Like it raining, for example, where I am in South Africa, it rained today. So there was a chance that it rained or not rained. Okay, I don't know if that makes sense, but the idea of probability is all about chance. And what we do when we do probability calculations is we try to figure out numerically or with numbers the chance of something happening or not happening. All right, so if that makes sense to you, let's move on to how we do this numerically. How do we do probability with numbers? Well, what we use is a scale. So the idea is, oops, that's my eraser. The idea is that probability lies on a scale between 0 and 1. Okay, so if something has a probability of 0, it means there is absolutely no chance of it happening. So let me think of an example. So you being born on the 32nd of May has no chance, no probability. Because if you think about it, I'll give you a second, there's no such thing as the 32nd of May. So there's no chance that you can be born on the 32nd of May. So that would be a probability of 0. A probability of 1 is a definite chance. Now, it's almost impossible for definite things to happen. Now, we'll talk about probability of 1 because when it comes to combinations of events, we often use 1 as our baseline, but we'll talk about that a little bit later. Okay, so now that we've established the ends of the probability scale, what lies in between? Well, everything else, and pretty much everything lies in between. The probability of it raining, the probability of you falling up the stairs, if you own stairs, the probability of the power going out if you live in South Africa, the probability of you passing your exam, the probability of you understanding this video. All of those things are chance based. And that's all got to do with events and stuff like that. But we're not interested in what causes the probability. We're just interested in the probability itself and the numbers because we're doing maths and maths is all about numbers. In probability, we give our results in 2 different ways. Well, you technically can give it in 3 different ways, but in Cambridge, which is specifically what I teach in the Cambridge syllabus, we usually give it as decimals or as fractions. For example, I can say there is a 0.5 chance that it's going to rain today. What does that mean? That basically means there is a 50% chance it's going to rain today. If we have done conversion from decimals to percentages, you'll understand that. But the idea is that there is a half chance it's going to rain today. We could also express this as a fraction, 1/2. All right, so the idea is that we can express probability as either a decimal or a fraction. You can also give it as a percentage, but we rarely do that in Cambridge. All right, so now that we've kind of established what probability is, let's look at a specific scenario in which we can apply our knowledge or our basic knowledge of probability. So I am going to rub this out so that we can come up with a scenario. All right, so the idea of the scenario that we're going to have is a bag of beads. So this is my little terrible bag, all right, and there's some beads in there, okay. So let's say I know I'm drawing specifically in purple now, but don't count the amount of dots that it is not going to be accurate. But for visualization, there is beads in a bag. All right, let's say there are 20 beads in this bag. All right, 20 beads. Now, let's say there are 4 different colored beads in this bag. So there is a total of 20 beads in the bag, and there are 4 different colors. So let's say 4 of the colors are blue. So 4 of the beads are blue, apologies. Let's say 5 of the beads are purple. Let's say 7 of the beads are yellow. Ooh, we can't really see that color, but you can see that it's yellow. And let's say we need to do very quick maths. 4 of the beads are red. All right. So if we were to count all of these numbers together, it should, in theory, add up to 20 because there are 20 beads in the bag. Okay, so we have 4 blue beads, 5 purple beads, 7 yellow beads, and 4 red beads. Now, remember I spoke earlier about events. So in this scenario, or in this situation, an event would be you or someone else putting their hand in the bag and randomly pulling out a bead. Now, probability would help us determine the chance of you getting a specific color bead. What happens if we get a specific question? Okay, I'm going to go back to my purple. Where is my purple? There it is. Okay, so let's say we get a specific question of what is the probability? I have to write this now. Probability that I get a yellow bead. If there are 7 yellow beads in the bag out of 20 beads, then we simply say the probability of getting 7 yellow beads divided by the total, which we said was 20 beads. And that would be your probability, 7 out of 20, because 7 of the beads are yellow, apologies, out of 20 of them. I hope that makes sense. So that's where basic probability comes in, is the idea of turning that into a fraction. Now, if I use my calculator, I can say that 7 divided by 20 is equal to 0.35. So we could also express it as a decimal. So there is a 0.35 chance of getting a yellow bead. All right, I hope that makes sense. We could apply the same thing to purple beads. So if I've now been asked, instead of yellow beads, let's say the question instead said purple beads, then I could say 5 out of 20 because 5 of the beads are purple out of the 20 beads. All right, so another scenario that we can look at is potentially selecting people at random. So I'm going to create another scenario. So instead of putting beads in a bag, because I don't know if you're anything like me, that's a slightly different color. I don't know if you're anything like me, but I can't remember a time in my life where I've actually pulled beads out of a bag. But I have been in a classroom before. So let's use a scenario of people in a classroom. So we've got a certain number of people in a classroom. Let's say we have, oops, that's a classroom, not a classroom. Oopsie. Let's say there are 37 people in this classroom. And there's a teacher. We're not counting the teacher because we're specifically looking at the students in the classroom. So there are 37 students in the classroom. Let's say we are asking these students what their favorite color is. we can express it as a frequency table. I don't know if you've done frequency before. If you haven't, I hopefully will soon be posting a video on statistics and frequency tables. But if you haven't, then make sure that you go and look up another YouTuber if you don't understand. So we have favorite color. I'm just going to write FC for favorite color. And we have the frequency. And if you don't understand frequency, it's basically the number of people who like a certain thing or who buy a certain thing or who are a certain thing. Okay, so let's say we ask people who their favorite colors. So we've got the favorite colors of, I have to change my pen quite a few times here. That looks like orange, even though I've written red. Let's say blue. Let's say, I'm just going to use the basic colors. So if I don't have your favorite color, I apologize. So you can barely see yellow. Let's do a pink. And, now I have to pick another color. Let's do green. I haven't done green before. Okay. All right. And you can see behind me my green wall and my green nails. So I really like green. Okay. So let's say, out of the 37 students, I'm on green, so I'm going to start there. Out of the 37 students, let's say 10 of them like green. That's their favorite color. Then with pink, let's say only 5 of the people like pink. All right. Then we can say, I've got yellow next. Then we can say 4 of the people like yellow. All right. Then let's say, we're at blue. 9 of the people like blue and 9 of the people like red. That's a slightly different color. I want to draw this in actual red now. Okay, so 9 of the people like red. So this would be our frequency table. We've been given all of the different values of how many people like each individual color. All right, so how do we calculate the probability? Well, it's exactly the same as when we had the beads in the bag. If we have 37 people, what's the probability of the teacher pointing at a person randomly and their favorite color being blue? Well, 9 out of the 37 people like blue. So there's your probability. And then remember, we can divide it on our calculator, or if you're very clever, you can do it in your head. I can't do that calculation in my head. And it would be 0.24. Rounded to 2 significant figures. All right, so that would be the probability of the teacher pointing at a random student who likes blue. All right, I hope that makes sense to you. We would do the same thing if it was green, pink, yellow, red. We would just put the specific probability we're looking for divided by the total number of people or number of cars or number of beads or whatever the total we are looking at. All right, that is basic probability. Okay, so now that we understand the basics, it's time for us to understand a little bit more complicated questions. How do we make probability more complicated? Well, the way that we do that is by adding more events. So when we talk about events, we are talking about certain things that are happening, as I said earlier, like you eating dinner, falling up the stairs, picking a bead out of a bag, picking a child in a classroom whose favorite color is blue. Those are all different events that we undergo. But what happens if that person who is picking beads out of a bag does so twice? So let's do a visual demonstration. I've got a bag, I pull out a bead, and then I pull out another bead. Those are 2 separate events. Okay, because I've done something twice. Now, when we do something twice, it's very important to understand that that is 2 separate probabilities. Now, this is where probability makes people's minds go, okay? Because in order to calculate the probability of both events, we need to first individually look at them separately and then put them together. So what do I mean by that? Let's take the beads in a bag, okay? So we've got our beads in our bag again, okay? Now, let's say I pull out a bead. Woohoo, there's my little bead, okay? Then I pull out another bead from the bag, Okay, for those of you who have done quite a lot of probability and you're asking yourself, is this with replacement? Is this without replacement? Don't worry about that right now. Remember, we're talking about the basics. For now, I want you to understand that we're pulling out 2 beads. Okay, now because we're pulling out 2 beads, there will be 2 separate events. Now, each event has its own probability. And in order to figure out the probability of both events happening, we have to multiply the 2 values together. All right, so let me show you an example. Let's take a slightly different example, just so that we don't overcomplicate it a little bit. Let's say that there are now 30 beads in the bag. All right, so I'm just going to use this color again, or this is slightly different. So there's 30 beads in the bag. All right, so let's say we have 3 different colors this time. So we have 11 that are red, or the orange. We have 9 that are pink. And we have 10 that are blue. All right, so this is the amount of beads in the bag. Okay, so what is the probability of pulling a blue bead and then pulling another blue bead? All right, so for those of you who, again, are a little bit more used to probability, we are going to do this question with replacement. What that means is that once you pull the bead out the bag, you're not going to put it down on the table, you're going to put it back in the bag. Okay, but that doesn't matter too much right now. We are again going over the basics of probability. All right, so let's say the question asks us to figure out the probability of picking a blue bead 2 times. All right, a blue bead and then a blue bead. Now pause for a second. What was the word I just used? Let's repeat the sentence. A blue bead and then another blue bead. Now, for those of you who have done probability before, you'll understand that the word I used was and. Now, if I use the word and in probability, that means I'm going to multiply. So not always is the word and used, but if the sentence makes sense with and, then we multiply. Okay, so I just want you to, in probability, link the word and multiplication. All right, so let's answer the question. The question is, what is the probability? Probability of picking 2, I forgot to finish that word. Picking 2 blue beads. All right, so there's no and in that sentence, but why am I linking the word and now? Because if I were to explain the scenario to someone else, I would say, I'm picking a blue bead and then another blue bead. The word and makes sense, okay? The other word in probability that we can use is the word or, which we'll talk about a little bit later. Let me try and say the same sentence with or. I am picking another probability or and then another probability. See, I can't even finish that sentence. It makes no sense. Okay? So we're using the word and. When we have 2 scenarios, we have to look at them separately and then we multiply them together. So the probability of picking a blue bead is 10 over 30 because there are 10 blue beads divided by the total of 30 beads. Now, another blue bead would also be 10 over 30. So to find the probability of both events happening, we multiply the 2 fractions together. And 10 over 30 times 10 over 30, if you're not very good at mental maths, you can put this in your calculator, although I would recommend you practicing your mental maths, especially if you're doing IGCSE, because of the new rules and regulations for the calculator and non-calculator paper. But remember, 10 times 10 is equal to 100. And if you're not sure what 30 times 30 is, we can do 3 times 3, which is 9. And then we add 2 zeros. And 100 divided by 900 is 1 over 9. So the probability of picking a blue bead and then another blue bead is 1 over 9. Or if we put that in our calculator to get our decimals, it's 0.11 chance. All right, so now that we've covered the word and, let's think about the word or. Now, or in probability basically means that we have options in the same scenario. So again, I want you to listen to me very, very carefully because it's really important to understand the distinction between and or and events. So let's say I have my bag with beads. Now I've got my eraser again. I've got my bag with beads. All right. So with my bag and my beads, if I pick out a bead, I take this bead, then I take this bead. All right, can you hear the word and again? I have two separate events because I've picked two blue beads. All right, I didn't pick them up at the same time. What I did was I picked one up, put it back in. Then I picked up another one and put it back in. Those are two events because I can put an and in that sentence. But what happens if I have options? So for example, let's say the question asked us, what's the probability? What's the probability of picking a blue or pink bead? Okay, now here is the word or. Okay, now that is the same event because I'm either picking a pink bead or a blue bead. And if you remember, there were 9 pink beads and again, there were 10 blue beads. So if I have that, again, I'm still investigating my probability separately. So let's start with the probability of the blue bead, which we've already established is 10 over 30 because there were 30 beads, right? Now, the probability of a pink bead would be 9 over 30. Now, in the previous scenario, we picked a blue bead and then another blue bead. So we multiplied the two probabilities together. But now we're looking at the word or. Okay, now if you see the word or in probability, it means addition. Okay, because that is options within the same event because I'm only picking one bead, but what's the probability, sorry, I can't even say, I've said probability so much today. The probability of it being pink or blue. So I take the probability of blue, I take the probability of pink, and I add them together. So if I add a fraction, remember they need to have the same denominator, which they do, so we don't have to do anything fancy. So 9 plus 10 is 19 divided by 30. So that is our probability of picking pink or blue. So now that we've covered the basics, what's important now is that we do some practice questions. Now, I know this is already a long video, but bear with me because being able to apply this knowledge is very important, especially in Cambridge, because in Cambridge, it doesn't help that you just regurgitate the information. You also need to be able to understand the information. So I have a practice paper for us over here, which has a couple of questions that I would like to go over. Okay, I'm scrolling a little bit, but I just want to find a specific question that I'm looking for. All right, so I'm going to be doing question 6 with you. All right, if you would like access to any of the past papers that I've made, I make topical papers a lot. Please let me know down in the comments and I can maybe reach out to you and send you some specific topical papers if you're interested. All right, so let's have a look at question 6. So here we have a bag. Now we've got a lovely bag. Again, it's all about bags in probability. So we have a bag that contains 5 red balls and 3 blue balls. Okay, so before I'm even looking at the question, I'm asking myself, well, if there are 5 red balls and 3 blue balls, how many balls are there in the bag? Well, we may need to add those. So that would be 5 plus 3, which is equal to 8. Okay, so there are 8 balls in this bag. Now it says, Sophie takes a ball at random, notes its color, and then puts it back in the bag. All right, so let's act out that scenario. Sophie picks out the ball, looks at the color, puts it back in the bag. And now she does this a second time. Now remember, we're speaking about events. So that means 2 separate events are happening. She's looking at the ball, putting it back, looking at the ball, putting it back. 2 events. Okay, let's just keep that in the back of our minds. Now it asked us to complete this tree diagram. Now I have not covered tree diagrams before, which is why I'm specifically looking at this question, because I'd like to help you with tree diagrams. Okay, so the first value has been done for us. Now the idea with a tree diagram is that it's the options we have. So we could either pick up a red ball or a blue ball. And in these lines over here, you need to place the probability. Now, we've already established that there are 8 balls in the bag. 5 of them are red, 3 of them are blue. So they've already said that to get a red ball, it's 5 over 8. So what would be the probability of blue? Well, there are 3 blue balls out of the 8 balls in total, so it would be 3 over 8. Now, to fill in the rest of the diagram, because she puts the ball back in the bag, it's exactly the same. Because we haven't lost any balls. There's still 8 balls in the bag when she picks up the second ball. So we have 5 over 8 for red and 3 over 8 for blue. And we can say 5 over 8 for red and 3 over 8 for blue. All right, so that's how you fill out a tree. You're basically just linking the correct probability to the correct branch. All right, so then it says, work out the probability that both of the balls she takes are blue. So let's put that into a sentence. The probability of getting blue and then blue. All right, so what's the probability of getting a blue ball? Well, it's 3 over 8. Now, what's the probability of getting a blue ball the second time? Well, it's 3 over 8. And what did we say the word and means? Well, we said it means multiply. So because we are getting a blue ball and then another blue ball, we multiply those 2 probabilities together and we get 3 over 8 times 3 over 8. If I'm looking down, it's just my calculator. And we get the probability of 9 over 64, okay? Which, if we put into decimals, is 0.14. All right, so the probability of getting a blue ball and then another blue ball is 0.14 or 9 over 64. So the next question I want to do is one that we haven't exactly covered yet. So we're going to jump right back to the beginning of the video where I spoke about the scale. Now remember I said to you that the scale is between 0 and 1. Francesca spins a 4-sided spinner numbered 1, 2, 3, 4. So we've got a spinner that we spin and there's sides numbered 1, 2, 3, and 4. The table shows some of the probabilities of landing on each number. Now these numbers seem quite daunting. We've got 1 and 0.18, 2 and 0.21, 3 and 0.37, and 4 doesn't have a value. Now we are asked to complete the table. This is where the scale comes in. Because remember that all probability, and this is a sentence I want you to remember, the maximum of probability can be is 1. Now, if I have a dice, for example, now we all know that a standard dice has 6 sides. Now, when you roll the dice, do you think it's going to land on an 8? No, because there isn't an 8 on the dice. So the probability of it landing on 1, 2, 3, 4, 5, and 6 is certain because those are the only sides that are on the dice. So in this case, our spinner has only 4 sides. The probability of it landing on either a 1, a 2, a 3, or a 4 has to be 1. Now that can be quite difficult to understand. So with these kinds of questions, it's important to understand that this table, these values, all need to add to 1. Okay? So in order to answer a question like this, you are going to add the 3 other values you are given. So we'll add 0.18 plus 0.21 plus 0.37. So if I do that on my calculator, that's going to give me 0.76. So that means All of these probabilities added together are 0.76. Now, the last probability needs to get us to 1 because it's certain that we're going to get at least one of the 4 numbers, right? So in order to figure out what the unknown number is, we simply say 1 minus all the numbers added together. And if we do that, we get 0.24, which means that that is what you put in the unknown block. Okay. All right, I hope that made sense to you. So any question like this, you can approach in the same way. You add all the values together, and then you say 1 minus that value, and that will give you the answer. All right, so it says, on Monday and Tuesday, the probability that the train is late is 0.2. We need to fill in the tree diagram. Now, if the probability of the train being late is 0.2. Now remember we said that all probability must add to 1. So what's the probability of it being not late? Well, we can say 1 minus 0.2 because that'll give us what's left over. And whatever is left over will be the probability of it not being late, which is 0.8. If you're not sure, you can do that on your calculator. All right, so we can say 0.2, 0.8. So we know that the probability is 0.8 because if we add these two values together, we get 1. And all probability adds to 1. All right, so now that we figured out the tree diagram, let's look at the 2 questions. What is the probability that the train is late on both days? Okay, so let's quickly look at the diagram. The probability that it's late is 0.2. Then it is late again. Sorry, let me repeat that sentence. And then it is late again. So we have 0.2. And remember, and means times. So we then say 0.2 times 0.2, which is 0.04. And that is the probability you write down. All right, then we've got a probability of it not being late on Monday and it being late on Tuesday. So we look at the diagram and we think, okay, so it's not late on Monday. So that means we look at 0.8. The and is even in the sentence for us. So then we're multiplying it being late on Tuesday, which we look is 0.2. So what's 0.8 times 0.2? Well, that's 0.16. And that is our probability. So I hope I helped and I made a little bit of sense. Please let me know if you have any questions down in the comments below. I know this video was a little bit longer. I do intend on posting an advanced probability for IGCSE as soon as I have the time, because that's where it gets really tricky and you really need to understand things like replacement and order, and we really go into that and or again. But for someone who is writing the core IGCSE maths exam, this is the information that you need to know. All right, I hope you have a fantastic rest of your day, and I hope this helped. Thank you. Bye.